Cool. Thank you, Anthony. Well, I'm sure need those drinks right now. A lot of people today. I'm not really used to speaking in the public like this, but so bear with me if anything. So, my name is Propan. So I'm the staff software engineer in test from the Walt Disney Company. So in case, I'm going to give you a background a little bit because of the products and nature of the products that we are going to go into might kind of cause you some questions. So the Walt Disney Company is not just Mickey Mouse and cartoon characters. In fact, we have a lot of products under the umbrella, like ESPN, sports channels and stuff, and we're just acquiring Fox. So you can see that there are a lot of diversity, like the film, like the Marvel or Lucas film, Star Wars. So those are all under Disney. So that tells about the nature of the product that we need to test. Will be various. Well, we have a lot of things from front end to the back end. My group specifically works on the supporting the SPN product at this point to make sure that the product that support the website, that power the website, is actually running okay. So my role is to come up with the strategies and also come up with the test automations and work with the team to go over those automations to make sure that those APIs have a good quality and that will result in the good guest experience. And again, we call our user base, like people who come out, log in, or going to the park, we call guests. So because we also have a client, which is the internal business unit that we are using as well. So if I mention the term guest, then please understand that it's going to be kind of outside people trying to come and use the system. All right, so today I'm going to talk about or share the idea about the DevOps in QA. You might have heard a lot about DevOps. It's been a buzzword in the past 5 years. Everything DevOps, this and that, all DevOps. Yeah, I go to eat DevOps, right? So what is DevOps? There are many definitions and a lot of meanings online, of course. When you Google it, tons of things pop up, and some of them are different, some of them are the same. So, so that we focus more on the kind of 3 pillars, which are the development, testing, which is QA, and also the operations. If you don't know operations, think about the SRE, or site reliability engineer, who deploy stuff or have knowledge about like Linux. Then they can go install software or do maintenance of the servers. So those are ops. The responsibilities of the DevOps around development, deployment, troubleshooting, maintenance, and validation, which basically we can summarize in the term of having the development plus testing and plus the ops, right? So those are all that we actually focus on today. And as I mentioned, there are a lot of meanings and definitions online, but I like one that seems to summarize it very well from Amazon AWS is, so DevOps is the combination of the cultural philosophies, practices, and tools that increase an organization's ability to deliver application service at a high velocity. So that's a keyword. Why we have DevOps? Because we want to make it quicker, but to make it quicker, you need to come, it comes with a bit of cost too, right? You move too fast, then you might fail later. So that's why our job as a QA is very important to keep those quality in check with this kind of fast-paced environment. Now, quality assurance, I'm sure everyone knows about this. Yeah. So it's basically just to maintain quality of a product or service in every stage of process. So the word quality is not just, I don't want you to go into just the functional or the testing only. It could be anything that is related to the product, such as you might think about performance, you might think about UX or user interface experience. That also considered as the quality as well, right? So you think about, if you put yourself in the user's shoes, you will find that if I come into the site and it's slow, well, I get mad. I'll just go somewhere else. So that also user experience. So the quality assurance as us, one of the main job is to keep those quality in check and make sure that the quality is good for users. Then they can use it smoothly. They can use it without any issues. Now, come down to today's topic, DevOps and QA. It usually is the other way around, which is going to be testing in DevOps or QA in DevOps. But what does it mean to do DevOps and QAs? The focus of this meeting and this talk is pretty much about the DevOps tools, which has a variety of tool set that we can use in QA. So the first one is to leverage the necessary DevOps tool set that we can enhance the validation process. So I'd like you to think about the tools that you have seen every day, like Jenkins or something like Docker. Those things it's not far from reach, right? We can actually use that. There's no limitation of just having to be ops or dev that can use those. QA, we can use that as well. And that will actually help us a lot in terms of speeding up the test or make it more convenient. The next thing is to leverage automation to expand the test capacity. Again, testing is just not about writing the test automation and call it testing, but in fact it's actually cover a lot of things, including monitoring, or even something far like try to improve the user experience. So with the monitoring, for example, monitoring, it could be a testing just because a lot of people would think that testing would limit it to just, hey, I'm just going to test until it releases to the production, and my job is done. The fact is no, because at that time it goes out to the guest or the users, and they will actually see the actual bugs or anything like that. It's going to be a really bad reputation for your product, right? So it's the place where it's getting real at the time. So we still have to monitor that and try to make sure that the user experience is actually also good in there. And the last one is to maximize the test effort, efficiency by using all the knowledge that we have, such as the architecture, infrastructure, build, and deployment. So QA is not just about testing the features as a lot of places define, but it's also concerned about you have to understand or have a deep understanding about the architecture itself, because once you have the good understanding toward those basic foundations of what you are testing, it could open a lot of doors for you to go into out of your comfort zone, and also can tackle something that it's never meant to happen. For example, you might think about writing automation is similar to Java, Python. In fact, you can actually use some part of the cloud features, such as AWS, by injecting some chaos testing in there. That is also called testing as well. So testing is never been limited to just writing automation or try to do manual testing, but it could do anything by any means to make sure that the quality of the product is acceptable. Now, let's see about the tool set a little bit. So we have many tool set in DevOps, such as the platform, starting with a platform on the left side, Google Cloud, Azure, AWS. They all provide nice features to let us test nicely. EC2, ECS, that we can spin up environment, or even spin up our test to actually run against the environment in certain regions. Kubernetes, Docker, Chef, Jenkins, GitLab, they're all orchestrations that can help you or can help the test be put into the right place at the right time. Imagine when we build the product, right? Sometimes we can use Docker or Kubernetes to spin up the whole environment, run the test against it, and then shut it down. So that is also maximize your test automation as well, because in that with that practice, you are actually trying to get the feedback early, And that is also going to step into another practice called continuous testing, which is we keep testing, we test fast and test anywhere. So this tool will enable us to do those benefits and can retrieve those benefits easily. And we have GitHub, GitLab that we can actually keep the code checked in, and I'm sure you all know about that. Check in the automation in there, pull it down, execute it using Maven, Gradle. So enough into two set examples. Now let's jump into the testing a little bit. So before DevOps or any new testing paradigm actually got invented or got created, so the normal flow would be developers will create the code, check it in, and then artifact will get built by the build engineer, which then send it over to the ops, say, hey, it's ready. We can deploy it now. Ops comes in, pulls the artifacts down, and then deploy onto static environments. And then it's up to us, QA, to come and validate those deployments. So you can see that a lot of hops have happened, and a lot of time has spent. It's such a waste of time to do 3 steps without doing anything about testing at all. And I'm sure that a lot of you might have heard about the bugs that found in the later stage would cost a lot more expensive than the bug that found in the early stage. In this case, once the bug is found at the testing, in traditional testing, it will be fixed, or it will be returned to developers, and everything will be repeated again. What caused that? So you have to go through that again. The build engineer has to be involved, and then ops has to come in and deploy that again. And those takes hours, takes days. So if you keep repeating doing that with the agile system, then what would happen? We spend so much time fixing something that is actually and deploy something that we're not supposed to lose. To get back a little bit, do you know that QA engineer is ranked as a really number 2 on the happiest job ever? Yeah, 14. So there's a reason to that. I guess after this, then there's a reason why we are not in that list anymore. So in the modern testing, it started the same way. Developers will check in the code, but now the job of the build engineer and ops combined into the automated system, which is the build system, which will build the artifacts uploaded and then deploy onto the environments automatically. And then test engineer comes in and validate, or test automation will be triggered automatically in the build pipeline. But there's more to that, because the validation could also happen even before the check-in happened. Has anyone heard about the term branch testing? So it's a very common practice or popular practice that we actually put the test during the development phase so that we can get the feedback in time. And that, a lot of DevOps technique and tools will be used to enable that to happen. And another thing is we can validate it in the build system as well. So again, testing is not just writing automation. It's also leverage the tools such as the code coverage analysis, or something like the static code analysis, to tell what the quality of the products as well. And this model, a lot of you guys might be familiar with the concept of the CI/CD, which will be kind of roll into this modern testing as well. All right, so now let's see the samples of the scenario that we have done at Disney. So sample number one is going to be the backend service that returning unpredictable responses. So this one, my team has encountered that during the discovery phase, when we go and trying to test a product, and we find that the product is connected or configured to underlying service, which provide the response, and then API service will roll that and to be its own response and serve it to whoever requested. So the problem and the challenge is, because when it's unpredictable, it's really hard to get the expected output, right? I mean, you're all tester, understand that we need expected output to compare with the actual input. Then what happened with this? We can't test it because the test keeps failing. We thought it would be A, and it turns out to be B, and playing catch up all the time, from B to C, C to D. So we leverage the DevOps by using Docker and YMOX service. So with the YMOX service, it's the mocking service that help or allow user to configure the API, configure API and configure the response that you need. Then it will, in this case, it will help make the unpredictable data become predictable, because you can supply all the response upfront and then use it in your testing. So in the component over here, API service, we go there and then we analyze the architecture and infrastructure and put the YMOX service instead of to replace the underlying service. And YMOX service will provide all the data needed to the API service. This way, we can retrieve the expected response back to when we test API service. But it's not ending just that, because with this way we can test on our machine pretty well. But when there's a place like build pipeline where we need a lot of automations, how do we do that? Because no one will go in there and keep starting or keep like initiating the service all the time, right? And that's where when Docker comes in. Anyone familiar with Docker? Awesome. So Docker is a containerized service which will help you think about VM. It's not a VM, but it behaves the same way with VM, that you spin up VM and then running something in there. Same thing, to help you kind of quick understand that. In this way, we use Docker to orchestrate it or wrap around these two services, the API service that we are testing, and also the YMOX service. So what happened is we can configure the API service to point to YMOX inside, and then we spin up the whole environment or ecosystem before testing. And once we check or validate that it's complete, then we run our test automation to validate all the input and the output that we expected. With this way, we can solve the problems where the unpredictable data return by putting the known data in the mocking service, return it out to API service, and run automation against that. And with Docker being so lightweight, it allows you to put that in the pipeline, in the build pipeline, like Jenkins or TeamCity in this case that we use. It will spin up during the pull request. Let's say that when developers make a pull request, it's gonna branch out to do this validation. So what happens is Docker Compose will get triggered. It will instantiate the API service and then YMOX. Once they both are up and running, we send some traffic through to validate that it's actually working. And once passed, then that's the time where we'll run the test automation against that. And this is the first example of how we use DevOps to help with testing. Because you imagine if you don't have YMOX, we don't have Docker, how do we test this? It's almost impossible, right? Because you have to keep guessing what data will be returning. And that would be really challenging for us. Now let's jump to the sample number 2. Again, ESPN, yeah, the product has a lot of good stuff, but also sometimes, of course, we encounter some challenges as well. But we make sure that things got covered before it goes out to the fans or users outside. So we have the team outside, the team in ESPN talk to us and say, hey, we keep having some problems with the data. That return is wrong. And the root cause was because that data was configured by human. See, human is a problem, right? That's why we have to go automate it all the time. So that data got configured by human, and sometimes human made mistake. So it ends up in the link mismatch or the link just missing. And what results in that is the ESPN Plus, which is the native service, we'll lost a lot of revenue because imagine if people want to replay the game, or let's say in this case it's the Ultimate Fighting, UFC, MMA. So people want to go and replay the match, but they can't just because the link is not there. So what happened? They just go somewhere else and try to find from some other providers. Now Disney lost revenue. So how do we do that to prevent that from happening? And that is also considered as a bad guest experience. So we tried to prevent that by we implemented the monitoring. And if you remember, we discussed about this a little bit in the beginning about testing is not limited to just writing the test before it goes out. After it goes out, also counted as a testing as well. In this case, it's very sporadic. It could come in anytime, any place, anywhere. So what we did was we implemented the monitoring service and then spin it up and run to test against that service frequently to detect the problems and then report it out to the user. The DevOps tools that we use in this case, we use Docker and a lot of AWS features, and also Slack. Anyone using Slack here? Or awesome. So it's Slack is a communication channel, more like Link or MSN if it's not too old. We can actually set a lot of configurations that we can do it programmatically to send to send the message through that. So what we did was, first of all, on the left side that it has ESPN, so that's a product that we call system under test in production. This system is running and sometimes gets some bad data in. So what we did was we implemented the monitoring service in the center using Java, very common. And then we packaged that into Docker again. See, Docker had come to play again. To make it more platform independent, we can deploy Docker anywhere and can run it anytime. And Docker can still also allow us to enable the testability for our tool as well. You can see that we don't just implement the tool, but we also test our own tool as well, which is really important. If we keep telling developers like, hey, your software is bad, your software is bad, so what happens if our own software is bad, right? So we cannot neglect the fact that we need to test our own tools and testing or test automation as well. That's really important. So once we wrap up with Docker, we throw that inside the AWS. It's called ECS. Before we go there, let me ask how many people use AWS before? Okay. And Google Cloud? Azure? Wow. All right. Great. So I believe I never used personally. I never used Google Cloud or Azure before, but I believe it should be pretty much the same thing. There should be similar things in there, which is in AWS they have the feature called ECS, Elastic Container Service, which will support the containerizations. So in this case, we wrap our monitoring service inside Docker, and then we throw it in ECS, and it will just spin up and try to scale and do the checking, hard checking. If it's crash or failure, then it will just restart it itself, which helps us a lot to make sure that it won't just crash or shut down itself. So with that, it's not enough because apart from the AWS ECS, we also use SNS, which is a simple notification service, help to send out the email and text message. So basically, we don't just report it through Slack once we find a problem, but we also call to the cloud-native features, such as the SNS, to help send out the email and text message to your phone. So with this way, it's very interactive, and people will get to know when the data got corrupted or the data is missing. Before we develop this tool, the team has to go in before every match start and then try to click through every link to make sure that everything is working, which is very painful. I'm sure that at one point you guys all did that. So it's very painful to keep monitoring manually. So with this tool, it helps a lot for people to have some more time to do something else besides just sit at the monitor and then just clicking through things that they know it could or could not happen. So, and also, that's right, to help investigation even more smoother, we actually throw in the log file, which will be kept onto S3, so that we have the storage in S3 that we can set up and keep the history, so that maybe one day you want to collect the stats, how many times it fails in certain link, or how many times that the data is missing, right? We can actually use those history record to gather data and then becomes a trend. So that's the sample number 2 that we use DevOps to help with the testing. In this case, it's more monitoring. So we really implemented the tool for using the development skills, and then also use the DevOps to actually come and help wrap it around. Now, the sample number 3 is going to be another perspective of how to use the DevOps. So another challenge that we have when we tackle the ESPN product is one of the teams asked us to validate something that has the underlying service as well. If you remember the first sample, we were talking about the unpredictable data. So this is also the service that has the same behavior, but unfortunately the same solution doesn't apply, only because this service also support really high number. There's a large number of APIs. So what we target was only 500,000 APIs, but in fact it could go up as high as 20 million APIs. So what happened when we run that, when we create the tool to compare the response from API? Maybe 10 APIs would be okay, maybe 100 APIs would be okay. It depends on the logic and everything that we set up, right? But if you think about response, and also latency, also how long you calculate and compare, so that could take up like hours and hours. So the challenge is the team really wants the product to be tested in the pipeline, which means that you cannot just trying to build something and then let them wait for 6 hours before knowing that that build is passing or not, right? So it's going to be really tedious to do that. So the goal is to check whether when they make the change on any APIs. So just to touch back to the background a little bit, we cannot use the mock solutions or mocking service solutions just only because there are too many APIs. So what we did was we just compare the old version and new version, and we assume that it should return the same thing, of course, with some exceptions on some certain fields, and that's how we come up with the solutions on this. So what we need to do is we have to create the tool that will create APIs for these two versions and report the results out if they're all clean or some of them are different and why it's different. So it sounds simple, right? But the simplicity doesn't stop just that. Because the server is located in Bristol, Connecticut, so on the East Coast. But our base is in Seattle. So what would happen? You have to cross the continent from the West Coast to East Coast in order to compare the API. Of course, 10 APIs would be just seamless. But think about 500,000 APIs. It's going to be a lot. So that results in our system actually costs about 7 hours to finish the comparison at first. And that doesn't sound good, right? So just because we need to make a call across the continent, and that caused some latency in that. So we analyzed the problems and found that, oh, hey, it's actually the server is in Bristol, and we are trying to make the call from Seattle. Duh. So what we did was we leveraged the AWS features like EC2 or ECS to actually spin up in the right region, which is now. We move our test into the East Coast region, and that helps reduce the latency by a lot. And it's expected to be okay to run in the build pipeline, which is more on within 15 minutes or half an hour. So with that, it's very simple. So this is another way of using DevOps to determine whether the test is in the right place or not, right? And then if it's not, then we just use whatever that they provide, AWS, Azure, or Google Cloud. Oh wow, okay, it's too far, then move it closer. That's simple. If that's not clear enough, let's try the target data is in Asia somewhere. Now, from Seattle to Asia, that would be a big number in latency. So what happened is, we can actually set up AWS in Singapore or somewhere close by, and then do the same thing. Simple, right? So if you don't have knowledge or some DevOps options to do this, then we might need to kind of really bear with the latency and sit at the computer for like 8 hours, and with the computer occupied all the time. That would be fun for sure. All right, so that's how we did things at Disney, trying to leverage some DevOps, and of course there are a lot more that we did, such as we leveraged DevOps into continuous testing. We spin up using Jenkins, and we leveraged everything that we could to actually do the testing and trying to make it more efficient. So just to recap, what the takeaway from this is I want to encourage you guys to look into more options to do the testing, not just enough or limited yourself to only write the test automation, because there are a lot of tools out there that could help speed up your test, that could help make your test more efficient, or sometimes it could actually make your test even like one click away from being complete automation. So I want to encourage you guys to think about that and probably go out and find more. Because in the new modern testing, I don't think tester will be limited to just writing test automation anymore. It will combine knowledge of a lot of DevOps and development. You can see from SDET, right? It's the QA plus development. And I'm not going to be surprised if the new skills in the next 5 years would be, hey, you have to be DevOps in order to do testing, just because it will help you a lot. It will save you a lot of time. So keep improving yourself, learn more about the tool set, because these days a lot of tools has been created, and I'm sure you won't have to create it yourself. Just learn about that and build something on top of that that would get you to the right place and do the right testing. So that's all DevOps in QA for today. Any questions? Or it would take the silence as the punishment. Okay, all right, well, cool. You can find me anytime. I will stay until the end. So if you have any questions, just let me know.
Thank you very much.